Yeah, guys, welcome back to another video. Today, in the series of anti-infective agents, we will be talking about antiviral and anti-AIDS agents. So, without any further ado, let's get started. First, we will talk about what is a virus. So, a virus is an obligate parasite which requires a host organism to replicate and produce the viral components, and which leads to infections. So, what are viruses? Viruses are obligate parasites. Now, what do you mean by obligate parasites? Obligate parasites imply that a parasite which is dependent on others for its survival. That is, without now if you ask me if virus is living and non-living, I will call it a obligate parasite. That is, it is living while it is in the host organism, and it is non-living when it is outside a host organism. So why does it require this host organism? It is so that the virus can use the mechanism or the machinery of the host organism in order to replicate and to produce viral components. Now this, after replicating and producing viral components, it will lead to infections. Now there are types of viruses. Now viruses are classified on the basis of their nucleic acid structure. That is, we have RNA virus and DNA virus. In RNA virus, we have picornavirus, which causes polio, hepatitis A, rhinovirus. Then we have retroviruses like HIV, which will cause HIV. DNA viruses, we have herpes virus, that is herpes, it will cause herpes and cold sores, and adenovirus, which causes respiratory complaints. In pox virus, we have, it will cause smallpox. Now, what are antiviral agents? Antiviral agents are the substances which are used in the treatment and prophylaxis of diseases caused by viruses. Now, the classification is based on two things. First is the disease state, and the second one is the chemical nature of the compound. So first we will go to the disease state. So according to the disease state, the antiviral agents are classified as anti-herpes virus agents, anti-influenza virus agents, and anti-hepatitis virus agents. And then we have one more. So in the anti-herpes virus, we have edoxyrutin, acyclovir, valacyclovir, famciclovir, ganciclovir, valganciclovir, cidofovir, foscarnet. Now for the ease of remembering, what we'll do is we will separate edoxyrutin, cidofovir and foscarnet. So we have edoxyrutin, cidofovir, foscarnet in one team, and the other one will be acyclovir, valacyclovir, famciclovir, ganciclovir, valganciclovir. So we can remember that valacyclovir plus ganciclovir will give us val and gan, so we have valganciclovir. So acyclovir, famciclovir, valacyclovir, ganciclovir will give us a valganciclovir. Next we have edoxyrutin, cidofovir and foscarnet. Now in anti-influenza virus, we have two types of influenzas, that is influenza A and influenza B. For that specifically we have amantadine, rimantadine in one team, and the other one will be oseltamivir and zanamivir. Now, anti-hepatitis virus or non-selective antiviral agents. In this we have now we have primarily for hepatitis B and primarily for hepatitis C. Now for hepatitis B we have lamivudine, then adifovir and tenofovir. Whereas for hepatitis C we have ribavirin and interferon alpha. In antiretrovirus, that is for, these are drugs for HIV, human immunodeficiency virus. So in this we have 6 different classes. So first we have the NRTIs, that is the nucleoside reverse transcriptase inhibitors. Now in nucleoside reverse transcriptase inhibitors we have zidovudine, didenosine, stavudine, lamivudine, abacavir, emtricitabine. Now this one nucleoside. Now in nucleotide we have tenofovir. So T for tenofovir, T for nucleotide. Okay, so in nucleoside reverse transcriptase we will have both nucleoside as well as nucleotide. So you can just mention that this is a nucleotide reverse transcriptase inhibitor. In nucleoside reverse transcriptase inhibitors we have zidovudine, didenosine, stavudine, lamivudine, abacavir, emtricitabine. And in nucleotide reverse transcriptase inhibitors we have tenofovir. Now, non-nucleoside reverse transcriptase inhibitors, that is, we will call it NNRTIs, we have nevirapine, efavirenz, and delavirdin. So, nevirapine, efavirenz, and delavirdin. In protease inhibitors, we have ritonavir, atazanavir, indinavir, nelfinavir, saquinavir, emprinavir, and lopinavir. So, the most commonly used drugs over here are ritonavir, indinavir, like very rarely but used, and lopinavir. Next we have entry or fusion inhibitors. So in entry or fusion inhibitors, we can take the name, we have enfuviratide. Now how do you remember enfuviratide? Remember entry En, fusion Fu, so enfuviratide. Next we have CCR5 receptor inhibitors. In this we have maraviroc. So CCR5 maraviroc. Integrase inhibitors, raltegravir. Now how do we remember this? Take the TEGRA from integrase and just add RAL in front. So we have raltegra and add a VIR in the end. Next we have the classification based on the chemical structure. Now based on the chemical structure, the antiviral drugs are divided into purine nucleotide and nucleoside. Now you remember we kept acyclovir, valacyclovir, ganciclovir, valganciclovir separately. All those come under the purine nucleoside and purine nucleotide. Now among pyrimidine nucleoside and nucleotide we have edoxyrutin, cidofovir. You remember we kept edoxyrutin, cidofovir separately, so that will come under pyrimidine. Then we have phosphorus derivatives. In phosphorus derivatives we have phoscornate. This also belongs to the first class, that is anti-herpes drugs. So phoscornate. Next we have admanthenamine. In admanthenamine we have admanthane. So this admanthenamines will be amantadine, rimantadine. Phosphorus derivatives, as I said earlier, phoscornate, and thiosemicarbazole. In thiosemicarbazole we have methimazole. Acyclovir belongs to the group of anti-herpes agents. So acyclovir, it has the general structure of a guanine group. So how do we draw a guanine? First we'll draw a guanine, that is a benzene ring attached to a 5-membered ring. In this 5-membered ring we have a nitrogen on the top, a nitrogen on the bottom, then we have 2 nitrogens right here, and here we will have a NH2 right here, and a double bond O right here. So these, to this structure we will add our hydrocarbon chain, that is CH2 O, CH2, CH2, OH. So this gives you the structure of acyclovir. Next we have the MOA of acyclovir. Acyclovir is converted to acyclovir monophosphate by the enzyme herpes specific thymidine kinase. So herpes virus specific thymidine kinase will convert acyclovir to acyclovir monophosphate. Then acyclovir monophosphate will be converted by various cellular kinases into acyclovir triphosphate. That is, here there was 1 phosphate, here there is an addition of 3 phosphates. So from 1 to 3, and this is caused by cellular kinases. Now this acyclovir triphosphate is the active compound which causes 2 different things. It inhibits the herpes virus DNA polymerase competitively, or it can get incorporated in the viral DNA and stops lengthening of the DNA strand. So the terminated DNA will inhibit DNA polymerase irreversibly. So it can inhibit it competitively as well as irreversibly. Next we have the uses. So the uses of acyclovir includes genital HSV, that is genital herpes simplex virus. Then we have mucocutaneous HSV, that is mucocutaneous herpes simplex virus, chickenpox, and then we have herpes encephalitis and herpes keratitis. Encephalitis is systemic, keratitis is topical. Then side effects include nephrotoxicity, malaise, fever, rash, fatigue, nausea, vomiting. Next we have edoxyrurin. So the MOA of edoxyrurin is it is activated by thymidine kinase. It gets substituted in the viral DNA in the place of thymidine, and it leads to faulty viral DNA formation and therefore inhibits viral replication. Now the uses includes, it is only used topically, that is for keratitis which is caused by HSV, and also for keratoconjunctivitis. Now the side effects, since it is topical, the side effects also would be topical, such as ocular irritation, swelling in the eye, itching, sensitivity to light and glow. Now how do we draw edoxyrurin? Now the structure of edoxyrurin is very simple, that is we have a pyramidin structure. So how do we draw a pyramidin? A pyrimidine would be, that is a benzene ring with two alternating nitrogens, then two alternating double bond O. Now for a pyrimidine we will add a CH3 here, but instead of CH3, since it is edoxyrurin, edo, so we will take this as iodo. So we will give a I instead of a CH3 group, and attached to this nitrogen down here we will have a 5-membered ring, that is a furan ring. Next to the furan, in the next position we will have CH2 OH, and then here we will have a OH group. Now if we remember acyclovir, in the hydrocarbon chain we had H2O, then two CH2s, so CH2, CH2, this was attached, and then we had a OH. Now the same thing is seen here, this is a CH2, then a O, then a CH2, CH2, OH, then again we have CH2, OH, and this has to be made into a 5-membered ring. So I'm sorry, I forgot the double bonds, so the double bond will come right here. So this is a structure of edoxyrurin. Next up we have zerovodin. So the mechanism of action of zerovodin is it gets converted into its active form of zerovodin triphosphate by phosphorylation, and then it inhibits the viral reverse transcriptase. Now since there is a single stranded viral RNA, it has to be converted to a double stranded viral RNA. The enzyme which is used here is reverse transcriptase. So what zerovodin will do is it will inhibit the enzyme reverse transcriptase. So there would be no formation of a double stranded viral DNA. So the side effects are neutropenia and anemia. The uses are treatment of HIV, that is prophylaxis and treatment of HIV-1, and treatment for prevention transmission from pregnant mother to child. Now this is the structure of zerovodin. For the structure of zerovodin as well, we will start with the basic structure of our pyrimidine. So we will take a benzene ring, alternating nitrogens, alternating oxygens, a double bond right here, and a pyrimidine is CH3 here, but we had not written it in edoxyrurin, but we will be giving it in zerovodin. So in here this is attached to a furan ring, then there was something here and there was something here in edoxyrurin. In zerovodin, here instead of OH we will get N double bond N double bond N, and so this one will get a negative charge because it has only 2 bonds. This one will get a positive charge because it has 4 bonds instead of 3, and here we will have the same, that is CH2, then a OH group. So the only changes here are this group right here and this group right here in comparison to, so this is a zerovodin. If we compare this with edoxyrurin, edoxyrurin has the same nitrogen here and nitrogen here. Attached to this we had a iodine group, so here iodine, and here there is a CH3. This is one difference. And then attach this to a furan ring, then we have a CH2 OH group here, and here we have a OH group which has 3 nitrogens here. there is a one OH group here. So these are the two differences. Next we have amantadine. So amantadine, this as we know, it is a anti-influenza agent. So it inhibits viral uncoating and viral assembly during the viral replication. It inhibits the release of viral nucleic acids into the host cell by inhibiting the viral M2 protein. Now there is a viral M2 protein which is required for the replication, so that will be inhibited, and it will also inhibit the release of viral nucleic acid. Next we have it will also inhibit the viral uncoating and assembly during viral replication. Now the uses includes treatment of influenza A, Parkinson's disease, insomnia, mental disturbances, ankle edema, anxiety. Now for the structure of amantadine, it's very simple. We will draw a benzene ring. Below that we will draw a W. Now we will attach this one to this one right here. Next we have, since it's an amantadine, that is advantine amine means we have to give it a NH2. So this is our amantadine. So that's all we had for today. I hope you all enjoyed the class. If you like the class, please give it a like, please share it with your friends. If you find it is very easy to understand, or if anything is difficult to understand, please let me know. And if you all have any suggestions for me, or if you all want any other chapters to be taken in between while we finish our anti-infective agents, please let me know in the comment section. And that's all we had for today. Thank you. Mogaso.